Welcome to DevSecOps. This time, kill the rebuild and true immutability. My name is Sven and I'm developer advocate for JFrog, and I'm talking today a little bit about pattern regarding repositories. So, kill the rebuilds and true immutability. This is the topic today. What I want to do today, I want to explain a little bit the ideas around repositories and what you can do to manage them more efficiently, and why these have something to do with DevSecOps. We will see. Okay, normally if you're dealing with Maven, Docker, Helm, whatever, you have always some kind of repository in the background. It means, for example, with Maven, you are just adding a dependency to your pom.xml, and then Maven will search in the local repository. Here it's called m.2, m2. It will search there for this dependency. If this dependency is not available, it will go to the reference repository. I assume that at least you have one repository in your own network. That means that if Maven now asks this repository, it will check internally if this dependency is available. If not, it will go to the declared parents. And normally this is Maven Central. So then the dependency will come from Maven Central, will be stored in your repository in your network, and after this it will stored in your .m2 folder, because Maven is just using it there and caching it there as well. This is a regular basic setup for dealing with dependencies. With other technologies, you don't have this .m2 folder, you have some other folders, but more or less it's always the same. So you have this local repository where you're going through, checking. If not, then you're going to your parent. This is a very common thing. And now there is one question, for example, how to deal with a tree of repositories. That means you have a repository inside your network, and this is maybe the first entrance to your network. So all dependencies from all other repositories or all requests are redirected to this main repository. And then you have a big company or different projects or products or whatever. You split up this hierarchy and you added several other repositories, because you want to deal in one repository with npm and Maven, and the other one just with Maven and Docker. And then you want to make sure that all these parts in the company are working together somehow. So team A is creating a dependency and pushing it to their local repository during the time they are coding and developing features. And then there is this dependency available. So the CI environment that's connected to this repository is able to find this one. If I have now a snapshot version or a version I want to share with my teams around, I have to think about what is the right target to push my binary through. It means a child is always a superset of its parent, because it has all from the parent plus the own local added stuff as well. The next one is, I have to maintain this content. If I don't want to have a repository with constantly growing and not releasing stuff, I have to make sure how I can do it. With Maven, for example, you can work or deal with snapshots. So you're working on an interim version, you're creating snapshots, and if you have the next final one, you can delete all snapshots if you want. But quite often, you don't want to have the snapshots, or some technologies are not supporting the snapshots. So you have the challenge that you must clean up somehow this repository. And if you're dealing with snapshots, you have the next challenge, for example, that some tools are caching and making sure that you are not constantly asking the parent. Normally this is good over the internet. You don't want to have a huge frequency or a high frequency of requests to the parent repository where everybody is asking. So you have this, I'm checking every 10 minutes, and then I'm just using what I have. If it is a miss or if it is a success request, doesn't matter, by just caching this result for 10 minutes. If you don't want to have this one because you want to speed up your pipeline, or you have dependent builds you want to trigger in your CI pipeline, so team A is triggering something and immediately you want to trigger a build on the team B because they're using this snapshot dependency, you don't want to have this caching algorithms. So what is the right way? If you want to share now some snapshots like this, you can run the regular builds inside your repository, and then if you decide, okay, this is a snapshot I want to share, you can push it to the father or to the Maven Central. So you have two possibilities. If you just want to do it internally, you can push it to the father, and then from this repository it's going down to all childs. Or you can do it like I'm pushing a version to Maven Central and then it's coming back to the internal network. Whatever you're choosing, you have to deal with this delays, and it's not really, well, you have to make a version and so on. So it's not so easy and not so good. So how to share between two branches of a tree, and then you have to make sure that you have the right target for every build, and how to deal, for example, with the situation you are pushing to your local repository. Build is green. Part of this build is now pushing to the parent, and this will fail. Should the whole build fail? Should only the last step fail? How to deal with it? So you have to cover all these tiny things, and one thing for sure is, or one bad thing is, it is a different process. So you're not doing constantly the same. You have to reconfigure, you have to make sure that the configuration is right and all this stuff. The other thing is, you could share a snapshot of the version control system, that you say, okay, I'm building now this snapshot with a snapshot of the source code number 1, and then I'm just sharing this snapshot. So if I'm going to the saplings, I'm just saying to them, okay, build everything based on this source code snapshot. And this means just, this is just the trigger to rebuild everything. So all the energy and all the tests you have run before, you're just running in the sapling as well. And this makes no sense, because you're just burning CPU cycles, money, and time. So sharing the source code snapshot and then rebuilding in every different part of the tree is not the best solution. So what can you do? In Artifactory, we have one very, very cool feature, and it's called virtual repository. And this virtual repository is, as far as I saw it until now, it's often just used to aggregate different remotes. For example, you have JBoss remote repository for Maven and Maven Central and some other things. Then virtual repositories are just used to aggregate different remote repositories under one logical name. This is one way. It's a typical thing as we had it before for caching. It's okay. But you can do quite more things with this virtual repository. One feature of this virtual repository is that inside this virtual repository, you can not only pull from it, you can push to it as well. So you can declare, if I'm pushing to the virtual repository, what should be the default target for this push. So you're pushing to the virtual one, and this is redirected to a dedicated local repository. So you have the pull and push, even if it is a virtual repository. So what can you do with this one? But first, let's have a look at the frequency of creating binaries in different steps. So during the feature phase, you're creating a lot of binaries and pushing it to the repository. So the frequency is very high. The next step, if you're now building on a feature branch and you're pushing this one to a repository, in the moment you're merging this feature branch to develop, you could delete all versions from this feature branch because they are not needed anymore, because the source code change is now on develop, and it will be rebuilt with other changes on develop. So it is part of the next binary of develop, and the develop snapshot builds are part of the next stage. So it means you can immediately delete a huge amount of this feature binaries and just going to the lower frequency of developer. branch binaries. And then if you're going from develop to staging, it will be even lower frequency of creating binaries. So with every stage, if you're going near to production, the frequency of creating a binary will be lower, and lower. On the other side, if I'm rebuilding a lot of, or if I'm creating a lot of binaries in the feature branch, and I don't want to have this one mixed up in my developer branch repository, so I should have for every feature branch an own repository. With Artifactory, this is not a big deal because repositories itself, the maintenance and all this stuff is very lightweight. So here you could do for every feature branch, you're creating your own repository and it will be merged at a point where you need the different binaries from feature branches if you need them. But mostly you can just work in a feature branch with a corresponding repository. Immediately if you are merging or develop, you can delete it. So, and this you can do for staging, prod and so on. But you can do more with this. If creating repositories is a very lightweight thing, and if a virtual repository is a very lightweight thing as well, think about long-running CI stages. So you have build step 1, 2, 3, 4, and so on. And you're creating web apps, for example. You're building the jar, you're doing some web tests, you're doing some whatever tests. So you have a long-running pipeline. If you are now using for this build a virtual repository, and inside this virtual repository you have a local repository for each build step, then what you could do is you're choosing for read for all stages the virtual repository, and every stage is pushing to this virtual repository as well. But from step to step, you're changing the default repository to the next local one. The first thing that's good, you have always the same configuration. The next thing that's perfect is if a build stage will just be red because it's not running well, or it's broken, it's a broken build, then you could just restart from this one, because every build step has its own repository. From a failed build, you're just deleting this repository and cleaning it up, so you can just go one step back and you have all binaries already built so far, and for every build step you can isolate every artifact that's pushed to the corresponding local repository. But the next build step will see the result of all build steps because it is asking the virtual repository. So with this, you can just kill the rebuild. So even if you have a long-running pipeline, you don't have to start from scratch. You just start immediately at this build step. You had positive done already. So this is what I want to say about, first of all, think about the possibility to deal with virtual repositories and speed up your pipeline, kill the rebuild, and it means every binary that is built once should be used as long as it's needed, and this is true immutability. Yeah, the bad thing is that you're trying it by yourself, and it's quite easy because you're just going to jfrog.com platform free trial. There you can ramp up a trial. It will take 10 or 15 minutes in the cloud. If you want, you can have a trial on-prem, but if it's just for the first test, I would recommend to do a trial in the cloud. Then you have Artifactory, X-Ray and all this stuff, because then you can connect, for example, with X-Ray to the virtual repositories, and so even every step will be checked for security and compliance issues as well. So just try it. How to do it? If you're dealing with Maven, for example, you're just creating a trial, then you are creating a Maven repository that's redirecting to Maven Central or whatever, and then you're creating a watch and checking what's going on in this repository. If you want to know how to create watches, policies and rules, check out one of my other tutorials. I have a very detailed tutorial about how to ramp up X-Ray and how to deal with the configuration here, but it's an easy thing. Then you're setting Maven up that's using exactly this created Maven repository. You have your Maven clean verify after you added your first dependency, and voila, you have a full checked result inside your Maven repository, and then you can just start playing around with virtual repositories, with different build steps, and so on. So, try it. It's a good thing. And let me know what happened. So I'm more than happy to get feedback from you. So please subscribe if you want to have more information on my YouTube channel, because there I will push step by step more and more of these videos. And yeah, try it. Ping me. The best way to ping me is Twitter. And yeah, have fun and see you. Today we want to see how to create your own test engine for JUnit 5. That means in the beginning we will have a short introduction about the possibilities of the default test engine. The agenda for today. Why we need Debian repositories, what's influence and what part of your infrastructure is. The next thing is why you should have an eye on it. What will this series about? It will be about functional reactive. And this for core Java means since Java 8